We all know the story of the extinction of the non-avian dinosaurs. Around 66 million years ago, a massive asteroid, as tall as Mount Everest, slammed into Earth with such force that it scorched the atmosphere like an oven and unleashed apocalyptic conditions across the globe. This catastrophe wiped out roughly 75% of all species in a very short time. Although it was not the deadliest extinction event in Earth's history, it is often regarded as the most sudden and destructive. For many dinosaurs, survival may have lasted only a single day before they vanished forever. Yet not long ago, within just a few years, scientists uncovered new evidence suggesting that this cataclysm may have been even more terrifying than originally believed. It now seems possible that the asteroid was not alone. In 2022, researchers identified a strange and enormous structure on the floor of the Atlantic Ocean while analyzing seismic data. This feature, now known as nadir, displayed all the hallmarks of an impact crater and was unusually large, measuring nearly 9.2 kilometers across, about 11 times taller than the world's highest skyscraper, though buried more than 900 meters beneath the sea. And since the Chicxulub crater sits off the coast of Mexico, one might expect this newly discovered formation to have been found nearby. And this was not a false lead. The structure was actually found on the opposite side of the ocean, off the coast of Africa, near Guinea to be precise. Of course, stumbling upon a crater does not necessarily mean much on its own, but when researchers examined the site, they discovered that it dated almost exactly to the same period as the end of the dinosaurs. In other words, around 66 million years ago, raising the possibility that Earth's rulers may have been struck twice by asteroids in quick succession. And naturally, given how close the timing was, scientists questioned whether this impact came from an entirely separate asteroid or if it had broken off from the Chicxulub impactor as it entered the atmosphere. To fuel this debate, a study released last year confirmed beyond any doubt that the formation was indeed created by an asteroid. However, the mystery of whether it struck on the very same day, slightly earlier, or shortly after remains unresolved. And this detail is far from trivial, because such a collision would not have been minor. It was powerful enough to leave a mark on the dinosaurs' extinction. Still, it was much smaller than the Chicxulub asteroid, which carved out a crater nearly 200 kilometers wide. Roughly 21 times larger, the nadir impact was still an incredibly rare event, occurring only once every 50,000 to 100,000 years. Scientists estimate the asteroid measured nearly 500 meters in diameter, several times larger than the YR4 asteroid, more than 5 times the length of a football field, and 10 times the size of the rock that caused the Tunguska event, which remains the largest impact ever recorded on Earth, and hopefully will continue to hold that record. The asteroid that created the nadir crater was not only exceptionally large, but also extraordinarily fast, slamming into the coast at about 72,000 kilometers per hour, roughly 11 times faster than the quickest tank shell ever fired. And keep in mind, this asteroid was around 4 billion times heavier. The result was nothing short of catastrophic, but the question remains, how devastating was it for the dinosaur? If this asteroid struck before the main Chicxulub impact, then any dinosaur or marine reptile that happened to look up would not have noticed anything until it pierced the atmosphere, suddenly becoming 24 times brighter than the sun. Its immense size and speed likely caused a partial airburst, producing local chaos, while the blinding brightness could have scorched animals that were too close. Then, moving at such incredible velocity, the nadir asteroid raced across the sky and crashed into Earth, releasing the energy equivalent of 5,000 megatons of TNT, more power than the world's current nuclear arsenal, according to some estimates. In an instant, a fireball larger than Central Park would have erupted at the crash site, heating the surrounding area, boiling the water, and setting ablaze any dinosaur unlucky enough to be near the coast. Based on late Cretaceous formations found in Africa, the dinosaurs present at the time could have included hadrosaurs, titanosaurs, and abelisaurids. For these creatures, burns would have been the least of their concerns. As the massive fireball expanded, scorching winds faster than hurricanes swept outward, uprooting forests and killing animals far beyond the immediate heat zone, potentially reaching hundreds of kilometers away. To put this in perspective, even an asteroid 8 times smaller could likely obliterate the entire city of New York. And while some of the asteroid's effects may have been softened by its ocean impact, others were made even worse, most notably the enormous tsunami that followed. At the impact site, the initial wave could have towered 3 times higher than the Eiffel Tower, engulfing vast stretches of land, while smaller, yet still massive waves spread across the Atlantic. These would have caused major destruction along distant coastlines and likely reshaped the shores of what we now know as North and South America. In addition, despite the cushioning effect of water, the nadir asteroid struck with such force that it fractured the ocean floor and triggered an earthquake measuring magnitude 7 on the Richter scale. In short, all these effects combined would have produced devastation on a local and even continental scale, sudden, violent, and catastrophic. Still, it is far harder to determine whether the impact reached a global level. For instance, even though the debris may not have been enough to overheat the atmosphere like the Chicxulub event, the asteroid still vaporized much of the seabed, and likely at the worst possible location, a vast black shale loaded with carbon and sulfur. Releasing those elements into the air was certainly disastrous, and it could have been enough to leave a noticeable mark on the global climate. And while it is not an exact simulation, an independent research team recently published a study showing that if Bennu, an asteroid of comparable size, were to strike Earth, it would be powerful enough to cause significant global damage. Pun very much intended. Their models suggest a worldwide temperature drop lasting 3 to 4 years, rainfall reduced by as much as 15%, and depletion of the ozone layer by up to 32%, with the severity depending on how far one is from the epicenter. Of course, this is only a simulation, and it involves a different asteroid. The effects are not fixed, yet they highlight just how deceptively destructive the Nadir asteroid could have been for its size. Ironically, in some ways, it might have been even worse than Chicxulub. When massive amounts of debris are thrown into the air, the dust tends not to linger as long. That may sound counterintuitive, but the reason is that a greater volume of dust collides and clumps together into particles large enough to fall back to the ground more quickly. By contrast, when less dust is released, the impact seems less extreme, but the fine particles take longer to settle, keeping the sky clouded for a longer period. This may very well have been the case with the Nadir impact, which could have triggered relatively prolonged climate disruptions. Taken together, all this evidence suggests that Nadir was more than dangerous enough to alter the course of the world. Still, the actual impact of Nadir on the dinosaurs remains uncertain, and it likely will until we learn more about the precise timeline. Yet, if it struck before the Chicxulub asteroid, it may have already destabilized countless ecosystems, leaving life across the globe more vulnerable to the larger blow. And if both impacts happened around the same time, the destructive effects of Chicxulub would almost certainly have been amplified, pushing the extinction rate to an even faster pace. That said, scientists agree that the Chicxulub impact alone was more than powerful enough to wipe out the dinosaur. With energy greater than 10 billion Hiroshima bombs combined, their extinction was a matter of when, not if. Still, one might wonder, without Chicxulub, could even a single additional species have survived to the other side? We can also question what such an impact would mean for humanity, and the outlook is sobering. The fireball alone would likely kill tens of thousands of people instantly along coastal regions, while the secondary effects could threaten more than 200 million, given how many major cities lie along the Atlantic coast. Nations would be thrown into chaos, and the economic consequences would be nothing short of global. And if we consider the Bennu simulation, we might expect food shortages and climate disruption, at least to a moderate degree. Even that alone would cause massive problems for human civilization. Altogether, it is a stark reminder of our species' fragility and of how truly disastrous it must have been to be a dinosaur on that fateful day. Thank you for watching, and see you next time on Echoes of the Past.